ENIAC, binary, and IPv6. In this video, we'll be discussing about the history of computers, how they work, and how the internet works. Let's learn. MathBus education. Computers have changed tremendously since they were first released to the world. In the early days of computers, they were the size of rooms and could only solve very simple math problems. The first of these giant machines was the Colossus Mark I, and it was released in 1943 to help decrypt Nazi communications. A year later, in 1944, the biggest computer ever made was released. It was called the Harvard Mark I, and it was built by IBM for the Allies in World War II. This monstrosity had 765,000 components, 3 million connections, and 500 miles of wires. To put that in perspective, 500 miles is a little under the distance between Columbus, Ohio, and New York City. Although the Colossus Mark I is technically the first computer created, the more well-known and often credited as the first computer is the ENIAC, Electronic Numerical Integrator and Calculator. The ENIAC was created in 1946 at the University of Pennsylvania and was the first general-purpose programmable electronic computer. Obviously, computers did not stay this big for long. Engineers have continually found ways to make computers smaller and more advanced. Over the 75 years since their creation, computers have evolved at an exponential rate. Think about this. The ENIAC weighed 25 tons and was 1,800 square feet, about the size of an average middle-class home, and could process 5,000 instructions per second. The iPhone 6, however, weighing in at 4.5 ounces and fitting in the palm of your hand, can process 25 billion instructions per second. That's progress. While the history of computers and how they evolved is somewhat interesting, what is really fascinating is how they work. In the beginning, when they started making computers, the creators realized computers had to follow some basic principles. They had to be able to receive input, store that input, process the information, then output the information so that others can see the results. Computers still use these basic principles today. Now we will get back to this principle in a moment, but first let's discuss how the computer transfers information. In a computer there are many wires and circuits. These carry information that is represented as on or off, yes or no, true or false, or 1 or 0. One of these wires by itself is called a bit, the smallest piece of information a computer can store. Adding more wires equals adding more bits, and more options for creating different combinations of ones and zeros. These combinations can then be used to represent more complex information. This is the basis of what is called the binary system. The binary system is used to represent numbers in our decimal system, using only ones and zeros. In the decimal system, which uses numbers from 0 to 9, each place has a certain value. The first position is ones, second is tens, third is hundreds, and so on. For example, if an 8 is in the third position followed by 2 zeros, that 8 represents 800. However, in the binary system, we use only ones and zeros, and each position increases in multiples of 2 instead of 10. For example, the first position is ones, second is twos, third is fours, fourth is eights, and so on. So the number 8 is represented as 1000, because 1 is in the fourth position, which is the eighths. Therefore, you would take 1 times 8, and since there are zeros in the rest of the positions, they are not added in. Let's look at another example. In binary, the number 1101 equals 13. There is a 1 in the first position, which equals 1. The 0 in the second or 2's position equals 0. The 1 in third or fourth position equals 4. And the 1 in the fourth position equals 8. When you add all of these together, it equals 13. So with that all in mind, if you had 4 wires, which makes 4 bits, you can represent a range of numbers from 0 to 15. Other things like text, videos and images, and sound can also be represented by numbers. By assigning a number to a letter, you can make sentences with binary by converting that number into its binary form. Videos and images are made up of using pixels, which have a color, and color can be represented by numbers too. Sound is recorded in waveforms that can be represented by numbers in the form of amplitude and frequency. Those too can be written in binary form. So with many wires, you can transfer a wide range of information from one place to another, and since electricity travels almost at the speed of light, our computers can output this information very quickly. No one in today's world uses binary to directly program because of the length of time that it would take. Now, we use programming languages, which use commands that are translated to binary. These commands are commonly in English instead of numbers. As you can imagine, this is much easier and more efficient than typing out millions of ones and zeros. Popular programming languages that you may have heard of are Java, Python, Ruby, HTML5, C#, and many more. Alright, let's get back to the main principle that computers go by, but in a more explained form. The input takes in physical outside actions, and then transfers it into binary information. The memory takes the binary information and stores it to give it to the central processing unit, or CPU as it is more commonly known. The CPU then calculates and processes the information and gives it back to the memory, where it will be sent to the output to be translated back into a compatible physical output. Now this usually happens very quickly, but sometimes big and complex pieces of information can take a little while. So many computers have multiple CPUs in memory to process that information more efficiently and quickly. This is the very basic explanation of how a computer works. Now we head into an area of computers that defies our lives today, the Internet. The Internet is like the postal service, except with binary information traveling through wires. Just like homes, computers have an address to receive or send out information. This address is called an IP address, and it traditionally consisted of 32 bits, which was called the IPv4 format. It allowed for up to 4 billion devices to have a unique IP address. That may seem like a lot, but with how many electronics people now own that connect to the Internet, it's not enough. As a result, we now use the IPv6 format, which uses 128 bits and 340 undecillion unique addresses, which means every grain of sand can have an address, every cubic foot of the earth could have one, and even with multiplying the population by 100, every person could have their own address, and there would still be leftovers. Usually when we go on a website, we don't type in the actual IP address. Instead, we use the domain name, such as www.example.com. When we are sending information from our computer to another, that information separates into smaller pieces called packets, and those packets will travel through different types of wires all the way to the destination. To make sure they all arrive safely, there are special computers called routers, which decide which route to take to get to the destination the quickest. All of this is accomplished through wires, but in today's world we are no longer constrained by wires. We have Wi-Fi, or wireless as it's also known. Wi-Fi works by sending information through radio waves from your computer to your wireless router in your home, and the reverse. From your router, it will carry the information through wires that connects all around the world. Of course, this is the more simplified explanation. There are much more complex processes at work to carry information using the Internet, but that is the basis of it. In this discussion, we have learned the basics of computers and the Internet as they are today. However, it is unlikely that it will always be this way. The world is changing all the times, and computers have evolved at a very fast rate that seems to continually accelerate. Who knows? Maybe in the future we will integrate computers in our own bodies, and the separation between us and the machines will become undistinguishable. Scary. Anyway, please leave a like, a comment, and subscribe down below, and thanks for watching.